Alright, you blokes, welcome. Thanks for coming. So today we're going to learn a bit about engines, so mainly just small vehicle, light vehicle engines. And that's out of the unit URTTE 104. So a little bit about that before we get too excited. This course covers the practical and theoretical skills needed to prepare for, perform and report on engine inspections and servicing, including diagnosing issues and completing necessary adjustments, as well as inspecting the components and their functions. So basically, we're going to pull an engine apart, see what's inside it, what looks good, what looks bad, and how to service it and keep it functioning well. But before we do that, if you guys need a toilet, straight down the left, drinks are over there. If you need a break any moment, just let me know, and we'll stop and suss it out. But before we get into the actual course itself, you guys have got a couple of quizzes. Just take 5 minutes to just fill those out and just see. I just want to get an idea what you guys know before the course, before we finish it, just so we can see if you've learned something. Hopefully, we'll go from there. So take 5 minutes, work on your own if you can, and then we'll jet back into it shortly. Has anybody had any experience with pulling motors apart and looking inside or anything like that, or just driving your cars around?
Just driving.
Nothing wrong with that. Good. That's what they're for,
That's it, mate. Well, we'll pay you.
No, shouldn't they?
Yeah, that's it.
You must know them all.
We'll see.
You should be running the class instead of me.
No.
Beautiful. He likes it. He likes it. Nice one. Mate.
Offhand was a bit dodgy. Bit dodgy.
Bit of graffiti. Nice. Nice, mate. That was good answers. Pretty good.
Stuff, mate.
Very close.
You don't just go, oh,
Alright, sweet. How you blokes going over there?
Who knows?
Good, mate.
Don't you dare overthink it. You can't have that.
I read the first one, I thought it was like, what is the check engine light for? Like,
Don't go down that rabbit hole, mate.
Nah.
Alright, beautiful. That's cool. So does anybody reckon they got half an idea what goes on? Or are they all just guesses?
half maybe?
Half an idea?
Yeah, half an idea.
Half an idea is good. Alright, so first step, I'm just going to outline the main components of a LVE's light vehicle engine because fingers get a bit sore typing that much. So we've got a crankshaft. I'm going to go over what that does, the big end bearings, end and main cap bearings, the pistons and all the bits and pieces within the piston, which are listed there, gaskets, cylinder head, valve, spring and valves, the camshaft or camshafts, and then the bearings for the cams as well. So we're going to cover a fair bit, but we're going to start with the crank. We'll start from the bottom and work our way sort of up to the top of the motor. So crankshaft converts the linear up and down motion of a piston into rotational motion to power the vehicle or other machinery. It does this by using connecting rods to turn the piston's reciprocating movement into the rotation of the crankshaft itself, which is then connected to a flywheel and the drivetrain to spin the wheel. So basically, what you can see here in this photo, if you can see that clearly enough, you've got these parts here, okay, that's in the middle. See how they're in a straight line? That's what's strapped into the actual bottom of the block. And these bits here, 1, 2, 3 and 4, that's where your pistons go onto, okay? So it's a 4-cylinder engine. and we'll get to where the pistons go soon. But so what happens is pistons and your caps are on these parts here. As it goes around, that spins. So obviously it needs to be lubricated up. So that's basically what the crankshaft does. So his whole job is just to keep things spinning and moving. So onto the bearings. So these little half moon bearings here, like I said before, they go on all these little parts here, I suppose. But in here mainly for the cylinders, for the pistons, so up there. And then they're held in by these caps. So again, they're all torqued to a specific specification. If they're over tight, they can seize. If they're too tight, they can come loose and cause rattling and knocking and all that sort of stuff, like in your car. So the big end bearing, main function of the big end bearing is to allow the connecting rod to pivot smoothly around the crankshaft while transmitting high loads of volume and force. So it's going up and down at 1,000 miles a minute. It's got to stay lubricated. And if that bearing does fail, it can make these parts of the crank here, we call it scoring, which means, you've got to pull the crank out, get a machine back to spec, and you're good to go again. And like I said, these little end caps, these two holes here, are what you tighten it down with. So that in your manual, it'll say how tight they need to be. So they need to be bang on. And again, these little bearings just go in that half moon piece there as well. So all lubed up, ready to rock and roll. The pistons, so piston is made up of the con rod or connecting rod, crown, skirt, gudgeon pin, compression and oil rings, and some clips as well. So I'm not sure if you can see this photo clearly, but this long piece here, that's your con rod, your connecting rod. Piston crown's a nice round bit on top, and the skirt which comes down. And through the middle here, you can't quite see it, but you can kind of see that's your gudgeon pin, and that's where it pivots to keep it nice and straight. And around here, that's where it connects onto the crankshaft. So like those bearings you saw before, bearing in there, top and bottom, and then your caps there, tied to the spec, and that's it. So that's how that works. And these little rings here, one's an oil ring and one is a compression ring. So the oil ring just scrapes the oil from the bore, keeping it into the bottom of the motor, and one keeps the compression in. If it leaks compression, it won't run. So that is what that one does. Okay, skip two then. No, I didn't. Okay, so gaskets. An engine's gasket primary function is to seal and prevent leaks between two mating engine parts, such as the engine block and the cylinder head, which ensures proper compression and keeps fluids like oil and coolant from mixing. So I've got two here. This is 4-cylinder, that's a 5-cylinder. So you can obviously see 4 holes, 4-cylinder, 5 holes. And these little holes here, we call galleries. So that's for coolant and oil to pass through to keep the engine either lubricated or cool. And slightly different sort of setup here, but the holes are the same basically. So what common thing that happens is you'll crack a head gasket, which you'll split sort of here in between cylinders. Can crack through here, but it's not really that common compared to cracking through here. So what's going to happen then is you're going to get some coolant into the combustion gas. So as you'll see, the coolant will be bubbling and spitting and carrying on, and it'll probably overheat and run like an old dog. So that's one thing that can happen. Some cars are more common than others, but at the same time it does happen. So there's no real way to prevent that. It's just luck of the draw sometimes. So obviously maintenance and that will help to a certain degree, but it's sometimes it just happens and you can't do much about it. So when you are building a motor again from scratch, you would get obviously a new gasket, and with your block you would get it lasered. I forget the exact word, lasered, so it's nice and flat. Machined is the word. Machined flat, so it's dead flat. So you new gasket on, so it's a complete seal, because if it's not machined right and slightly off, that's when things can go wrong.
What causes the gaskets to crack?
It could be anything, mate. So sometimes they've just been there for 500,000 k's and they've just had enough. That can be one of the things. They can get hot, they can overheat, and sometimes it can just happen. Like one of my friends was going home from the gym, got halfway home, and that was it. They drove here, no problem, no signs, just went kabang, and that was it. Wouldn't start. Towed it to us, then all of a sudden we did a few tests and we found that it was actually cracked in between here. So cylinder 2 and 3. And because they tried to start it 300,000 times afterwards, it just blew a hole in the head. So it wasn't just a gasket, it was the whole head. So it just happens. I mean, yeah, like I said, some cars like the ZD30s and Nissan Patrols, they're notorious for it. They blow head gaskets for fun. They love doing it. So it's kept us in business, of course, but for the customer, it's a pretty rough day. But yeah, it's just one of those things that happens, I suppose. But they're a small gasket. They're only very thin. There's usually 3 or 4, sometimes 5 layers of different things that keep it, nice and firm. But sometimes it just happens. So I guess maintenance for that would just be keeping the coolant obviously topped up and fresh, because sometimes just because it looks like it's got green or red corn doesn't mean it's actually fresh. It could have been there for a long time and not actually doing its job. So onto the cylinder head. So this gasket obviously sits on top of the block. Then on top of this gasket goes the cylinder head. So on the left is a bare cylinder head. So you can see here you've got, this sits over the top of the piston. So you've got one hole for inlet, one hole for outlet, or inlet and exhaust. They're just for your manifold either way, so they're not really that important for this topic. And see these galleries here, those holes will match up to these holes. These aren't the same for the same motor, but you're going to get the idea. So these holes all here will match up in theory with the holes on here. So these bigger holes are for your bolt holes to go down, so that's not really, nothing going through this, it's a big bolt, so I'm not going to worry about that. And this one here is assembled, so what that means is when you're doing a head, you can either opt to get it delivered bare with the parts or assembled. It just depends how much time you've got and what you want to do. So this one's assembled, so you've got all your springs, retainers and all that sort of stuff in the head ready to rock and roll, so there's no need to pull it apart and strip things out. It comes ready to go. So you put that straight on top of the car and you're good. So cylinder head is a crucial engine component that forms the roof of the combustion chamber, sealing it to the engine block and controlling the flow of air, fuel and exhaust gases through valves and ports. So the valves and ports we're going to sort of chat about now. So these are your valve springs. They're your valves, these two long rods, and they're just a little wash that sits on top. So valve springs ensure that the engine's valves close completely and quickly after being opened by the camshaft. Their primary functions are to seal the combustion chamber and maintain contact with the camshaft lobes through the system of pressure and return forces. So basically what you'll do, the spring goes, where are we? Yeah, okay, so the spring, let me go back to this head. So spring sits on the top there, so your valve goes all the way through. That little dot there is the top of your valve. That goes through from these holes here. And what you'll find with the valves is they're a different size. So you might be able to see it from here, but we can try. So that's slightly bigger than this one. So one side of your head, depending what it is, will be bigger. So that's just the way they've done that. Excuse me. So you press them in with a special machine, push the springs down, put that little washer, that's just there, that washer goes on top, and then these things here are called collets, and that just locks it all into place. So it'll sit as it does there. So the spring's been compressed, you've poked your valve through the hole and up to the top, which is the top of it there, squash it down with the machine, throw your collets in, that's your head assembled ready to rock and roll. So that's that one. So cams, or camshaft, so there's a few different variations of this one, but the main function of the camshaft is to control the opening and closing of the intake and exhaust valves in the internal combustion engine at the precise time. So these have to be bang on, okay? So most of the time you find a DOHC and a SOHC, which is a double overhead cam or a single overhead cam. So basically, single being there's one camshaft that does both open and close the valves of the inlet and exhaust. More modern cars have got a double overhead cam, which means one for inlet, one for outlet. Just so, I'm not sure why they've done it, but it seems to work out okay. So this bottom one here is a double overhead cam. So you've got one, let's just say this is the inlet side. So air comes in from this side of the motor. And these valves on the left here are opening to let air in. And then once it does its thing through the four-stroke mechanism, these valves on the right-hand side here will open. They will open and let the exhaust gases out. So that's how a double overhead cam system works. But if it was just one, as you can see there, it's just one cam and the lobes on either side do the opposite. So this is sort of what a camshaft looks like here. So you've got the front here, that's a scissor gear, so that locks it into another camshaft. And these are the mounting spots here. So you've got one here, two, up to five. So they sit on top of the cylinder head, which we'll get to the next part, which is the same as the pistons with the bearing and the cap on top. Okay, and then these lobes here, they're almost like a teardrop kind of shape, and that sort of spins in a circle as it will, but because it's an off shape, it makes the valves open and shut at different times. So where's that photo of the head? Yeah, so the cam lobes will sit on top of these little pieces here, and as it spins around in that funny shape, it'll make it close and open, still in a quick fashion, but also very timed fashion too. If that's out by one tooth and you start the car and run it, these pistons are going to touch the top of your piston and make an absolute mess and a horrible noise and be quite expensive. So we try and stay away from that if we can. Yeah, so in most cars, like I said, double overhead cam is what you're probably going to find. It's just easier, I guess, because it's one for each side. So you sort of, if you see there's a leak or a problem with one side, you can focus straight on that. So that's the cams. Like I said before, you've got the bearings and caps. So the bearings for the cams are exactly the same as the piston ones, half moon shape, just a lot smaller because obviously the cam's a lot smaller than the crankshaft, and then the caps are the same. So the reasons are, do them up with the bolts, and in your manual it'll say to X amount of torque, do it up to that, and you're good to go again. But on torque specs, I'll get to that in a minute, but there's a thing called plastic gauge. You guys heard of plastic gauge before at all? So what that is basically, I've only ever used the green stuff. I'm sure it comes in different colours, but you put a bit of that, let's say between on your cam and your cap. You put it on, you tighten it up to spec, you take it back off, and what the plastic gauge does is squashes down to whatever it does, and you take the cap off and you match up how thick it's squashed down to with your gauge, and you say, okay, so it's at this amount, I need it to be more, I need it to be less, rub it off, you do it again. But if it matches up good for in spec with the motor, you're good to go. So you do it back up to that spec, as you know it's going to be fine. But torque specs, engine building requires precise torque specifications, often found in the manufacturer's service manual, to ensure components like the cylinder head and main bearings are securely fastened to prevent leaks, distortion, and component failure. For many critical bolts, a torque wrench is essential, and tightening must often be done in a specific sequence and or in multiple steps. So when we're doing heads of work, you'll plot the head on. Let's say we've got 12 head bolts. So you don't just go bang, 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 bang. You do it from the middle. You do the two, then you sort of go opposite and backwards from there. Otherwise, you can warp the head and that sort of stuff. So you do it. The book might say, I think for a ZD30, it's about 105 newton meters for the start. So you do them all up to 105 in that sequence. Come back to the middle. You do, I think it's like another 90 degrees. So you set your bar up 90 degrees. Do that again, then it might say another 90 after that, so then it'd be bloody tight, okay? If that comes off, not a good day for anybody. So
What happens if you don't do it tight enough or too tight?
it can leak, so it just won't hold the pressure in there. So the car won't run, it'll probably lack compression, and it probably won't start, it'll just probably chook away for a while and nothing will probably happen. But that's why you do it in stages, and what I think a lot of people do it. You do the first stage, be at 105, 10 newton meters, get a pen on it, make a little mark, all going the same way. Then if you do your 90, the marks would go from that way, it's got to end up facing that way, and that's 90. Then once they all look like that, back and do it again, and it should be facing back towards you. So you've got to have it all pretty much bang on. But if it wasn't tight enough, I dare say it wouldn't have any compression in any cylinders, because it's obviously air's getting out. It's an airtight system in a way. So once the head goes on the gasket and it's all bolted down, no air gets in apart from what's coming into the motor, not anything else. Or it can't escape, I should say.
And if it's too tight, what happens then?
I don't think it's a problem being too tight, but it just could mean like if you need to take it off, and bolts can snap. If you snap a bolt in that, it's not good. So that's head off. But if you can't get the head off, what do? It's stuck on there. So I think that's why the specs are there. But doing something to 120 newton meters and then 90 degrees twice, it's bloody tight. The bars we use at this long, you get a run up and give it to it. It feels like it's going to snap, but these head bolts are made of pretty high tensile stuff. So I haven't snapped one yet, but it feels like it come close a few times. But I think it's all pretty good. But so that's all the theory sort of stuff there. Anybody got any questions, or anyone got a clue what's going on, or anyone lost, or
No.
No, you good?
It's fine, well, mate.
Good, mate. Beautiful. All right, so we've got a couple of videos, and just get our list for a minute. So this is just going to explain a bit more about it, and we'll go from there. So this is just a little 4-minute vid. Take notes, or if you want to, I know you haven't got pens and that's fine, but just take some mental notes if you need to, because this might be in the second quiz. So I'll just pop this up and have a listen to this bloke. We've got action.
A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air and turns the crankshaft. And the valves, which controls the flow of air.
Is this a single overhead cam or a double?
Double.
the
Good one, mate.
cylinders. Valves are driven by the intake camshaft and the exhaust camshaft,
Yeah, there we are.
and the camshafts are driven by the crank itself using a timing belt. There will be idle pulleys and a tensioner pulley to hold the belt tight in place. This here is the internal structure of a 4-stroke inline 4-cylinder DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes to complete one cycle to produce power. They are intake,
Just real quick too, I'll just rewind a bit, just check out what the cams are doing. Like I was saying before, how they're that funny shape. You sort of watch what they're doing to the springs as it sort of just rolls around.
to complete one cycle to produce
And
power.
watch this one, see how it's nothing,
They are
then
intake,
dips down.
compression,
So it's
power,
round for the
and
most part,
exhaust
and then it just
stroke.
dips it down, open it up
The
or shut
crank
it.
to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete 1 camshaft revolution. And the camshafts are designed in a responsive manner to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This
So
pulls
you
the
see how the
air-fuel
angle of the
mixture
camshaft is
into the
opposite? That one's up top, this one's down below.
Once the air-fuel
Working
mixture
in sequence
is in
together.
the cylinder, compression stroke begins compressing the mixture. At this time, both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crank shaft from stopping immediately. For a 4-cylinder engine, considering any time instance, 1 cylinder is always in power stroke, which produces more power and less vibrations comparing to a single cylinder engine. And that is how a car engine produces power in simple.
There you go.
Thanks for watching, gents.
Thanks for telling us, mate.
What's the purpose of the spring in the valve?
So that just pretty much allows you to push it down and come up. So it's always got tension on it at some point. So if you let the pressure up, it needs to be up so the valve shuts, basically. So, yeah. But yeah, that was obviously for a petrol engine. Does anybody know how a diesel engine operates in terms of ignition?
I know the glow plugs instead of spark plugs. Is that
Yeah,
right?
so glow plugs just heat the chamber up, ready to start.
Oh,
Once
okay.
that light goes off, they do nothing else.
Right, okay.
Yeah.
There's no spark, right? It like uses like the pressure to.
Yeah, it's just
Right.
ignited by the pressure and the diesel. Yeah, so there's no spark plug in it
right.
at all. So once it comes up, it's the same principle, the 4-stroke. So air comes in, comes up, comes back, getting on that one. Once it gets to a certain point, because there's no air escaping, it just goes bang and ignites it on its own.
Yeah,
Yeah,
doesn't
so
need spark.
No,
so.
it comes down and does it again. So it's exactly the same as that, but there's no spark plug. It just does it on its own.
Yeah.
So, but yeah, glow plugs, they're just there to heat the chamber up. So you hit the key, the
Oh,
little
yeah.
light will come on, and once it goes off, it's job done. They don't do anything else. So,
Is that
okay.
because the fuel type's different?
Yeah,
That's what-
yeah. So diesel, it's not as flammable as petrol, but the air fuel ratio, if you get that right, that's what makes it fire and crack. So, which I think is pretty cool. So, but diesel run a lot higher compression than petrols do as well. So, I'm not sure off the top of my head, but ours diesel cars are pretty high in compression. So, what's the next piece? Let's get this going again. Is that all making sense? Everyone's happy with where they're at. They've got a half an idea or more than half an idea now. Yeah, there's a bit going on with motors and that sort of stuff, but yeah, no, it's pretty good. So, all right, are there any other questions? Anything that you sort of?
just said if you turn the aircon off.
Oh, did you?
Yeah.
I'll do that then. Apart from that, is there any other questions? everyone's pretty comfy, good, what they're looking at? Okay, cool. So, we've got another quiz for you guys to do, just because 2 quizzes is always good. So, again, take your time. I'll just get these out again. We've got your pen still kicking around somewhere. So, if you weren't sure about any questions from the first one, hopefully that'll all make a bit more sense now, fingers crossed, and we'll see how you go. We'll sit like go next to that.
Chopping it big.
Little quick little yarn about the answers once you finish that, but yeah. Just gonna have a quick little drink again, but yeah. Take your time, you blokes. How do you reckon you went, mate? Is there anything that didn't sort of make sense?
I don't think I really remember the piston rings part,
Okay.
but definitely didn't know the stuff around camshafts
Yeah, yeah.
and like how that works with the valves before.
Yeah.
So that stuff a lot clearer.
Yeah. No, it's a very cool system when you sort of pull it down and have a look. But yeah, someone somewhere thought that would work and they've made it happen, so it is very cool. And it's just lucky that in my industry at work, there's always someone whose car's gone wrong. We get to do it all the time, which is great. So you just hang on to those once you finish. We'll just go over real quick, just see if we're all on the same page. Just waiting to bleed.
Yep.
You alright? Alright, so number 1, primary function of an engine in a light vehicle. What do you say? Seems good to me, that's it. Number 2, which engine component houses the cylinders, pistons and crankshaft? C, nice one. Good, everything's C. Right? They're all C. Function of the piston in the engine. So, what do we say there? C again.
Yep.
It's always C. What component opens and closes the intake and exhaust valves? Nice, very good, that's it. Crankshaft converts what type of motion? So keeping on crankshaft is spinning.
B.
Linear to rotational, very good. Purpose of the spark plug in a petrol engine? C. Lovely. Hang on, what's 7 on the front here? Which the following is a function of engine oil? Yes. If you didn't cover engine oil, that's pretty straightforward, I would have thought.
Yeah.
Main role of the cooling system?
B.
Yep. In a 4-stroke engine, which stroke draws air fuel mixture into the cylinder?
C.
Yep. Which part of the engine helps maintain proper timing of the valve operation? So we didn't cover this part specifically, but I think it's in the name.
B.
I think it wasn't one of your slides.
Oh, is it?
Yeah.
I would have. Yeah, I'm thinking of the wrong question. Oh, here we go. Yeah, this is the question I was talking about. Number 10. Which engine part helps maintain proper timing of the valve operation?
Oh, we don't know that.
Mr.
Timing
Belt.
belt.
Yeah, timing belt. Yeah. So I didn't cover those. That's sort of. I didn't go too much. That's another rabbit hole. I've been here for 3 hours talking about that sort of stuff. And purpose of the piston rings.
So,
Yep, beautiful. But it seemed like everyone passed, which is good. That makes me look bloody good. Right, well, yeah, a few C's in there. If in doubt, go C, I reckon.
take it home with it.
Yeah, that's
Yeah,
right. Yeah.
they can put that in the wall for
I
me.
made a rule.
Oh, thanks for you blokes. And just between now and the next session, if you want, maybe just go out to your car, pop a bottom, just have a look, see what you can find. Like you can find some leads on the spark plugs and all that sort of stuff. And just see if you can sort of work out what's doing what and where it's going. Because a lot of it's obviously cut up. You can't see all this sort of stuff. But just pull your engine apart.
Pop the bottom
Yeah,
on.
pull it apart. It surely just slide in front of you.
Yeah,
Just right in front of you. All right. Well, no, thanks for that, and hope you learned something. And we'll I'll see you in the next one. So, thank you.